Hi guys, today in this lab we are going to show you how to find the rate law for a chemical reaction. In this case, the rate is equal to a constant K times the concentration of iodide to the power of A times the concentration of persulfate to the power of B. So the idea of the lab is to find K, to find A and B. In order to find A, we are going to keep the concentration of persulfate constant, so in runs 1 and 2, and we're going to change the concentration of iodide ions. Now, to find B, we have to keep the concentration of iodide constant, so runs 1 and 3, and we're going to change the concentration of persulfate, as you can see here. The temperature is going to be room temperature, so we are going to keep it constant, let's say, to about 21 centigrades. We also want to kind of qualitatively study the effect of temperature in the reaction rate. For this, we're going to do 2 runs. The first one, we are going to put the Erlenmeyer, where the reaction is happening, into an ice bath. So the temperature is going to be about 2 Celsius. And to run a higher temperature, we're going to put this in a different Erlenmeyer, right, new reaction, in a warm water bath, and the temperature is going to be about 40 Celsius. So today we are going to show you one of these runs, one example of the reaction.
So this is what your setup will look like. You'll have a solution A and a solution B. In solution A will be our potassium iodide, sodium thiosulfate, if needed, potassium chloride, and our starch solution. And then in solution B, which will be in a small beaker, you'll have sodium persulfate and sodium sulfate. So, once you add your solutions to solution A, Erlenmeyer A, make sure you add your 2 to 3 drops of starch so that the solution eventually turns purple. And then when you're ready, you're going to pour solution B into the Erlenmeyer while you hit start on the iPad at the same time. Then you can put your temperature probe back into the Erlenmeyer to accurately measure the temperature of the solution.
So in the iPad, you will have 2 columns. In the first column, you have the time in seconds, and in the second column, you have the temperature in Celsius. Now, why do we add potassium chloride and sulfate ions to the solution?
So, in order to change the concentration of I- and persulfate, we reduce the volume of those the 2 chemicals that we add. In order to keep the total volume the same, we add potassium chloride or sodium sulfate solution.
So as you saw, the color of the solution changed. At that time, Pat stopped the iPad. So the idea is that when the color changes, you need to measure or take the time and the temperature when this happens. Now, what was happening here was the iodide ion was being oxidized by persulfate ions, producing iodine. This iodine immediately reacted with the thiosulfate ions that were present in solution. The reaction of these 2 produces more iodide ions. These iodide ions again react with persulfate ions to produce iodine. When all the thiosulfate ions are finished, all of them reacted, the iodine cannot go in this direction anymore. So what's going to happen then is the iodine is going to combine with the iodide ion to form I3-, and this I3- in the presence of a starch is going to give us this purple solution. Okay? Whenever we get this purple solution, that's the end of the reaction, and then you can collect the time and the temperature and continue to do the next run. That's all.